This question says to determine all the solutions of the following trigonometric equations for sine theta is equal to 0.263 within the interval 0 to 360 degrees. So the mere fact all is mentioned, it appears that there are more than one solutions for that equation in that interval, the interval 0 to 360 degrees. Okay, so we expect to get more than one solutions. Say all the solutions, all right? The reason why the question is allowed to demand that, to ask that, let's take a look at this information here in Unit 5E called Trigonometry Math is Fun, okay? Actually, this was taken from Google, Math is Fun, downloaded from the internet. So this is not my original work, okay? This was taken from the website Math is Fun, so I cannot claim ownership to this document, okay? Now, for the record, it says sine, cosine, and tangent in the 4 quadrants, okay? We studied the quadrants already, agreed? In this worksheet, that's our original work, okay? We actually developed this, the 4 quadrant. We are familiar with the characteristics therein. The first quadrant, everything is normal. That means all are positive, and we know why. The adjacent to this angle and the opposite to the angle are all positive. So sine, cosine, tangent are all positive. All right, and here you have it. The second quadrant. Now remember, we're talking about a counterclockwise direction. So 30 degrees acute is 180 minus. Okay, so 150 degrees counterclockwise is the same as 180 degrees minus 30 degrees minus the acute. So the acute is 30 degrees and the acute in the second quadrant is 30 degrees, but the actual angle itself counterclockwise is 150, stemming from 180 minus. So, you know, associate the second quadrant with 180 minus, and you can see why. Okay, because we're talking about a counterclockwise direction. In the third quadrant, we can see that we continue counterclockwise, and this is a 180 plus. So associate the third quadrant with 180 plus, and you can see the reason why. The acute angle is in the third quadrant, here it is, but the angle itself that was traversed is a 180 plus the 30. Okay, so associate the third quadrant with 180 plus. We are going to the fourth quadrant. We continue counterclockwise. Clockwise, sorry. You can say 360 minus, but you can even say 270 plus. Okay, you can say 270, but what 270 plus will not give you, all right, it will not bring you to the angle 330 degrees, because we're looking at the acute 30, so it's a 360 subtract the acute. So first quadrant, all are positive. Second quadrant, 180 minus. Third quadrant, 180 plus. And fourth quadrant, 360 minus. No. All is in the first quadrant positive. Sine is positive in the second quadrant, and we know why. Tangent is positive in the third quadrant, and we know why. And cosine is positive in the fourth quadrant, and we know why. So associate the second quadrant with sine, the third quadrant with tan, and the fourth quadrant with cosine. Okay, and we know why. Opposite to the angle is positive, hypotenuse is always positive, so sine is positive. Adjacent opposite to the angle is negative, adjacent to the angle is negative, negative divided by negative is positive, tan is positive. Cosine, adjacent to the angle is positive, hypotenuse is always positive, is cosine that is positive in the fourth. And this is summarized in this table here. Associate the second quadrant with sine 180 minus. Associate the third quadrant with cosine. No, the fourth quadrant with cosine 360 minus. And the third quadrant, so because they didn't put it in order there. Okay. Okay, second, third, fourth. So you have second, third, and then go back to fourth for cosine. Okay, and you have 180 theta plus 180, 180 plus. Actually, you should have put the 180. So you can see the limitations in the presentation. Okay, so if I would want to construct this, I would have put sine, tangent, and cosine. Okay, sine, tangent, and cosine. Probably want to keep that same sequence of SOHCAHTOA, I guess. So that's why they put sine, cosine, tangent. But first, second, third, fourth. First is all. Second, third, fourth. So second is sine. Third is tan, and fourth is cos. And 180 minus, 180 plus, and 360 minus. And in fact, if you put cosine last, it is, you know, kind of the odd one out in terms of 180 and 360. So, okay. So we can grab this little table. Take a snapshot of it. By actually solving some questions with its use, the learning will automatically take place. Okay. You know for sure that your test will be online, so there's no need to memorize the table, but by interacting with the table, you know, you'll automatically learn the significance thereof. Okay, so it says determine all the solutions of the following trigonometric equations for 0 to 360 degrees for sine theta is equal to 0.26. So you go to insert, you go to equations, and then you, so we can increase this now, increase this a little bit just for visuality. Okay, and type here theta now. That will give us our first angle, which is the acute. So in the calculator, when you type in the calculator, when you type sine inverse, okay, so just to give you a little pointers, if you are using, for the ones who are using the math equations, for you to get exponentiation, you don't really have to, you know, highlight the letter, the last letter, go to equations and go to script and then go to superscript. Okay, you don't really have to go that long route. Okay, and get your superscript and then put your -1 in the little dotted rectangle or square. You don't really have to do that. Okay, you can simply, after the last letter or symbol, whatever, just press Shift 6. Shift 6 will give you the upward arrow. That's another international notation for powering. And you just put whatever power is square in this term now is -1, and you just tab, and it automatically gives you power, you know, exponentiation notation of 0.263. So when you type sine inverse of 0.263 in your calculator, let's see if this calculator is compatible with math equation in terms of trigonometry. Sine inverse, enter, Yes, it is. So you are getting the first angle, which is the acute, and it will be in the first quadrant. Okay, it will be in the first quadrant, as you can see. Okay, which is 15.25 or 15 degrees. Normally, normally it is okay to round off degrees to the nearest whole number. Now, this is the first angle, that's the 15. So let's just go back to our little diagram. So that is where the all is. So this is our 15. Here it is. But we know sine is positive in the second quadrant. So to get that other angle, that other obtuse angle, okay, we have to do a 180 subtract the 15. Okay, so we can call that theta 1 with the subscript 1. Insert. We must go to equations to get the subscript. Theta subscript 1. Now, anytime you see you are inserting a subscript, that's a form of labeling. Okay, it's like the first theta. Always bear that in mind. You are not required to do anything when it comes to subscript. Superscript, yes, in maths you are powering, but when it comes to subscript, it's a form of labeling. So don't make subscript confuse you when you see it in mathematical notations. It's just a form of labeling. Okay, so the second theta, okay, so you can practice using subscripts. Okay, first theta is the acute in the first quadrant. The second quadrant will be 180 minus, sorry. Okay, because we have to subtract the acute from the 180 because the 180 is a straight line, bear that in mind. So sine is 180 minus, so 180 subtract 15 will give us the second. So bear in mind that looking like 165, but just to verify and just to demonstrate, you see. So we're looking at 165. 165, shift 6, circle, right? 165 degrees. So these are the orders because, in the third and fourth, sine is negative. Now, just to prove the point, if we find the sine of 165, we're supposed to get back 0.263. And here it is, 0.2588. Why? Because I rounded off. It was 15 point somebody, recall, it was 15.248, and I chopped out a little bit of decimals, so that's why we're getting 0.2588, which is 0.26, approximately. All right, so that's what you do for number 7. Please do that for the questions in the assignment itself.